for this next section, we want to look at sum to product identities. And we're going to start with the product to sum identity, and we want to kind of reverse that. So here we have one of our product to sum identities, and the trick is this part right here where we let alpha plus beta be x and alpha minus beta equal y. If we solve that little system of equations for alpha and beta, we get what we see down here, that alpha is x plus 2 over y, beta is x plus y over 2, beta is x minus y over 2. And so what we're going to do is just take and do a substitution. So in the equation up here, we see that we have the 1/2. So if we take and then get rid of that 1/2 by multiplying each side by 2. So that's the 2 that we see right here. Sine of x. Well, this alpha plus beta is x. So we're taking out the alpha plus beta, putting the x in its place. Then the alpha minus beta here is y. So we're taking out the alpha minus beta and putting y in its place. Then on the right side of the equation, we had an alpha here. But alpha, according to what we've done here, is x plus y over 2. So we replace that, and the beta here gets replaced with an x minus y over 2 to give us our final formula here. Once again, you may have these formulas written down on a formula sheet for the test. Let's look at how to apply them. So we want to find the exact value of cosine 255 plus cosine 195. Our formula says that the cosine of alpha plus the cosine of beta is equal to 2 cosine of alpha plus beta over 2 cosine of alpha minus beta over 2. So our alpha and beta here are 255 and 195. So we have 2 times the cosine of 255 plus 195 over 2 times the cosine of 255 minus 195 over 2. Working out our expressions in the parentheses, 2 cosine 255 plus 195 is 450 divided by 2, and 255 minus 195 is 60 divided by 2, or 2 cosine of 225 cosine 30. So thinking of our unit circle, cosine of 225, let's see, 225 would be here, and that is going to be cosine is negative in that quadrant, so negative radical 2 over 2. So we have 2 times negative radical 2 over 2, and the cosine of 30, which is the square root of 3 over 2. And that simplifies then. Let's see, we can do a little canceling there. So we have negative radical 6 over 2 for the final answer. We can solve equations using these formulas also. For our last example, our form for sine alpha minus sine beta is sine alpha minus sine beta equals 2 cosine alpha plus beta over 2 sine alpha plus beta over 2. So we start plugging some things in there. So we have 2 times the cosine. Alpha is 8x. So 8x plus 2x over 2. And the sine of 8x plus 2x over 2. And all that's to equal 0. So that's 2 cosine of 8x plus 2x. And I made a mistake there. That second plus should be a minus. So that's alpha minus beta, and 8x minus 2x. So we have the 10x divided by 2, or 5x here, and the sine of 8 minus 2 is 6x divided by 2 is 3x equals 0. We can next divide each side by 2 to just get rid of the 2. And you might be thinking at this point, well, how does that help? But notice that we have a product now. And so we can apply the zero product property and say that then cosine of 5x equals 0, or the sine of 3x equals 0. Let's see, cosine is 0 at pi over 2 and 3 pi over 2. So that means, and we got to be a little careful here, that 5x equals pi over 2.